Sounds crazy, doesn't it? But have you ever imagined that beyond Earth, the only place we know that harbors life, there could be distant planets silently nurturing life forms? This isn't just a sci-fi fantasy anymore. It's one of the most intriguing and profound questions driving the fields of astronomy, astrobiology, and astrophysics. The quest to find life beyond Earth isn't merely about finding water. It's about identifying the delicate and complex conditions that, like Earth, can sustain life. In this article, we'll dive deep, examining the latest discoveries and boldest hypotheses to uncover which planets might support life. From promising candidates like Europa and Enceladus within our solar system to super-Earth's orbiting stars like Proxima Centauri and the TRAPPIST-1 system. What does life in the universe mean? Before we can determine which planets might support life, we need to define what we mean by life. Are we looking for beings like humans or simply microbes? Most scientists focus on microbial life, the simplest and most adaptable form of life, capable of surviving in extreme environments. An often overlooked fact: Earth took over 1 billion years to develop basic microbial life, and billions more to evolve complex organisms. This implies that if life exists elsewhere, it might still be in its primitive stages. Essential conditions for life. Not all planets with water are habitable. Scientists have identified several key factors. Distance from the host star. Habitable zone: the planet must be in a temperature range that allows liquid water to exist. Atmosphere: to shield life from cosmic radiation and regulate temperature. Magnetic field: protects against solar wind and ionizing radiation. Geological activity: volcanism and tectonics support the carbon cycle and provide essential minerals. An often ignored but crucial factor is orbital stability. If a planet's orbit is too eccentric, it could experience climate extremes that hinder the development of life. Promising bodies within our solar system. Europa, moon of Jupiter. Europa is believed to have a vast salty ocean beneath its icy crust. Cracks on its surface, possibly from tidal flexing caused by Jupiter's gravity, suggest heat is generated to maintain liquid water beneath. Spacecraft like Galileo and Hubble have detected organic molecules and even water plumes, hinting at environments similar to Earth's hydrothermal vents, where life may have originated. Enceladus, moon of Saturn. Similar to Europa, Enceladus has an underground ocean and exhibits plumes of water. Cassini detected hydrogen in these plumes, suggesting possible chemical reactions such as methanogenesis, where microbes could produce methane from hydrogen and CO2. Titan, Saturn's largest moon. Though Titan is extremely cold with methane-filled lakes, it has a thick atmosphere and complex organic chemistry. This raises the possibility of alternative life not based on water, but on liquid methane, a highly debated and fascinating concept in astrobiology. Exoplanets with life-supporting potential. Proxima b, orbiting Proxima Centauri. Proxima b is a rocky planet, Earth-sized, located in the habitable zone of Proxima Centauri, the closest star to our Sun, 4.2 light-years away. However, it orbits a red dwarf, which may emit intense flares that could strip away its atmosphere. Still, a strong magnetic field or thick atmosphere might allow life to persist underground or underwater. TRAPPIST-1 planetary system. The TRAPPIST-1 system features 7 rocky planets, with at least 3 in the habitable zone. These planets are Earth-sized, reasonably dense, and closely spaced, allowing for easier study. A fascinating hypothesis. Planetary collisions could eject material from one planet to another, possibly carrying microbial life, a natural version of panspermia. Kepler 452b, a super-Earth in the habitable zone. Kepler 452b is about 60% larger than Earth, orbiting a Sun-like star. While its atmosphere remains uncertain, if it exists, life may have developed over billions of years, potentially even longer than on Earth. Underrated yet promising candidates. LHS 1140b, dense super-Earth with magnetic field potential. LHS 1140b has a high density, suggesting a large iron core, which could generate a strong magnetic field. It orbits a relatively quiet red dwarf with few flares. Ideal conditions for life. K2-18b signs of water and methane in its atmosphere. This is one of the few exoplanets with confirmed water vapor in its atmosphere, along with methane and CO2, potential biosignatures. Interestingly, K2-18b may have a thick atmosphere, allowing potential life forms to exist in its cloud layers, similar to theories about life on Venus. The future of the search, astrobiology, and new technology. With cutting-edge space telescopes like the James Webb, we've entered a new era in astrobiology. Spectral analysis from exoplanets can now identify biosignatures such as oxygen, methane, and ozone. Future missions like NASA's Europa Clipper and ESA's JUICE will explore icy moons in detail. These spacecraft will fly by measuring magnetic fields, analyzing surface compositions, and sampling plumes for signs of life. Conclusion: is life common in the universe? The search for extraterrestrial life isn't just scientific. It touches philosophy, religion, and humanity's future. Even finding microbial life would reshape our understanding of our place in the cosmos. Though no definitive proof exists yet, current discoveries suggest life might not be rare. It could be waiting in Europa's icy ocean or floating in K2-18b's dense atmosphere. Sounds crazy, doesn't it? But if tomorrow, the James Webb Space Telescope detects an anomaly in the light spectrum of a planet dozens of light years away, what if that's the universe's first hello?